In part 1, we chose our prop from the show, these streetlights, and we blocked out the basic form using reference along the way. Today we'll continue the process by adding smaller details and making further enhancements. We'll do a quick UV unwrap and prepare our asset for texture and rendering. This is where we left off. We have a basic blockout of the asset's form. If we look at the reference, we definitely want to get some cables running along the pole and ultimately into the light at the top. We also want to show how certain parts are attached, namely how the light is attached to the arm and how the base is secured to the floor. First, we need a bolt. Press F9 to get the parameter window when you create something new, like our circle. You'll get a pop-up somewhere in the bottom left usually that gives you the parameters, like how many points you want. If you ever lose that window by accidentally clicking away, you can always get it back by pressing F9. Let's lower the amount of vertices to something like 6. In edit mode, extrude up, extrude and right-click to cancel transform, scale in, and extrude once more down. If you don't know these shortcuts, this is all stuff that we covered in part 1. Now to fill this hole here, you can just press F. The problem is, you'll end up with a 6-point face. This is what we call an n-gon, because it has more than 4 points. We're looking to keep this clean and all quads, so Ctrl-Z to undo, and instead press Ctrl-F. This gives us this holy grail feature called grid fill. Select it and watch as Blender fills the gap with quads. If it doesn't look right, you can bring up your parameter pop-up with F9 to change the span or offset. Do the same for the bottom face. Now it's time to bevel. Remember from part 1, we should apply a scale in object mode before attempting a bevel. Next, go to edit mode, select all with A, now press Shift-N. This recalculates the normals. Another good trick to ensure things are cleaned up before we attempt a bevel. Now select all of the edges we want to bevel. Pro tip: if it's shorter to select the ones we don't want to bevel, just do that and press Ctrl-I to invert the selection. Now press Ctrl-B, scroll to get 3 edges. Apply and go to object mode. Right-click, shade smooth, subdivide with Ctrl-2. Now scale it down with S. Make a little base at the bottom of the pole so we can bolt it to the floor. Grid fill and bevel. Let's move the bolt into place. My initial base was comically large, so I scaled it down using another trick from our first video. S for scale, then Shift-Z to scale on everything except for the Z axis. Now I'll show you the fast way to array this bolt in a circle. First, select your bolt. Move it up so we can see what's going on. Note the orange dot. This is the selected object's origin. This is exactly where we want it to be. If it's not there, let me show you quickly how you can move your object's origin. There are 2 techniques. The first way is to come up here to our snapping menu and turn on vertex snapping. Now with our object selected, press Ctrl key. This will enter object origin mode. Press G to grab the origin. Now hold Ctrl to snap. Snap it to the bottom center vertex. Again, it was already there to begin with. Press Ctrl again to exit. That's method number 1. Go back up to the snapping menu and Shift select faces and edges. Now we're snapping to all sorts of stuff. Select the bolt, press G to grab, lock it to the Z axis. Now hold Ctrl to temporarily turn on snapping. You can see how it snapped to the surface of the base. That's snapping in a nutshell. We'll go over other features as they come up. Now for the second method of moving an object's origin, go to Edit Mode. There are 3 ways to view an object in Edit Mode. You can view points, edges, or faces. 1, 2, and 3 on the keyboard toggles each of these respectively. Press 2 for edge selection mode. Now select the edge where we want to move the origin to. Press Shift-S, cursor to selected. In object mode, right-click, Set Origin to 3D Cursor. That's method 2. It's more precise, but it takes more steps. Let's move the cursor back to the bottom and get everything back in place. So there's a little tangent to show you how snapping and origin control works in Blender. Now our origin is at the center of the bolt. Let's add a curve that we can use to guide the bolts around the base. Whenever possible, it's good practice to harvest new shapes from existing geometry. In this case, let's select the base and go into edit mode with Tab. Ctrl R to create a loop cut exactly where we want the bolts to circle around. Once you have this, we want to extract it from the mesh. To do this, press Shift-D to duplicate the ring. Right-click to cancel placement. Now press P. This is the separation menu. We want to separate the selected edges, so separate by selection. Go to Object Mode and select the ring. This ring is made out of points and edges. We actually want to convert it to a curve. To do this, let's use our handy search menu. It depends on how you set up Blender, but your search is either F3 or spacebar. Mine is set to F3. Search for Convert. Choose Curve because we want to convert to a curve. In edit mode, you can see we've successfully made this into a curve. Now, there are 3 steps for arraying this bolt along the curve. First, we need to control the origin point of our curve. We want the origin of the curve to be precisely where the origin of the bolt is located. Fortunately, we went over this already. Select the bolt first, press Shift-S, cursor to selected. This moves the 3D cursor to our bolt's origin point. Now select the curve, right-click, Set Origin to 3D Cursor. You won't see a change right away, but trust me, if you skip this step, you'll run into issues when trying to array the bolt along the curve. Now for step 2 and 3. We need to first array a series of bolts in a line. Then we need to tell the line to follow a curve. We can do this easily in the Modifier tab. Select the bolt and add an array modifier. You can choose which axis is arrayed on and how many to array. Let's put it at something like 6 and leave the offset alone for now. Now, add a curve modifier. It is actually important to do this in the order that we've done here. On the curve modifier, select the curve object with the eyedropper tool. Select our curve. Because we set the origin correctly, things are already working. Go back to the array and play with the offset factor. Increase from 1 to something else. I'm not too worried, so I'm just going to eyeball it. It's not a big deal to hand place these 6 bolts, but you can see how this could be pretty useful if we were dealing with hundreds of bolts, so I definitely wanted to teach it to you. To apply the modifiers, hover over Array and press Ctrl-A for Apply. Do the same with Curve. Now we can simply delete the curve. And that's how you array an object along the curve. It seems like a lot of steps, but do it a few times and you'll start developing muscle memory for it. And that's it for bolts. We learned about origins, snapping, and a handy technique for arraying along a curve. Speaking of handy techniques with curves, let's learn how to quickly add some cables to our light. There are some pretty cool add-ons out there for adding cables, but I want to show you a nice technique without tracking down and installing anything new. We do need one add-on that comes with Blender. Go to Edit, Preferences, and then Add-ons. Once you're here, you can simply just search for Extra. You'll see an add-on called Add Curve Extra Objects. That's exactly what we want. It gives us the ability to add a single point of a curve, rather than adding a whole curve. Let's go to our light and move our origin to this central point. Select the point, Shift-S, and cursor to selected. Now back in object mode, Shift-A to add something new. Add curve and then point. This is a simple curve. We want it to be 3D, not 2D. We also want this to be a Bezier curve. In edit mode, you can select the first curve point and press E to extrude. This works pretty much as expected. If you're not familiar with Bezier curves, basically you have these handles. You can adjust handle length and direction. There's no secret sauce here, just keep extruding, rotating, and shaping handles all the way down the pole. Try to keep the curve above the surface of the pole. It helps if you use snapping to snap things to the pole. You may also see me hit R to rotate and R again to change the rotation behavior to something that's more freeform and follows my mouse direction. Just a note here, I did end up experimenting with a shrink wrap modifier as well. Just select your curve and choose shrink wrap in the modifier tab. Then eyedrop the pole as the target object. I played with the offset to get the cable to hover over the pole. This was a little finicky, but I think I ended up really liking the results. It basically just helped me keep things along the surface of the pole at a predefined distance. Now we have our curve, it's simply a matter of adding some thickness. First, let's apply our scale by pressing Ctrl A for Apply and Scale. Now let's go into our Object Data Properties. In this case, it's a little green icon of a curve. Scroll down to and expand the Geometry tab. We want to increase depth. Hold down Shift before dragging this value to fine-tune the results. Things are looking a little flat and weird, and that's because our shrink wrap modifier is still on. Go to Modifiers and apply the shrink wrap. By default, it adds depth with a circular-looking cable. Let's say we wanted a more unique shape. We can actually define that back in the Object Data Properties. Instead of round, select Profile. Now you can draw your own custom profile. There are some cool presets here too. Feel free to get creative. The shrink wrap modifier also might have messed up some points in our curve. Take some time to hand adjust everything and get it looking right. Working with curves is a labor of love. One of the cool things about curves is you can always edit this after the fact. You might consider adding a few different cables to add visual complexity. If your cable is looking kinked in some areas, you might try deleting curve points. To finish things off, I'm going into time-lapse mode again to add a few geometry details, namely connecting points for the cord and connecting points for the light. I'm not really going into anything we haven't already covered in the first two videos. This is all pretty basic modeling technique, so I'll see you at the end for a very quick discussion around UV unwrapping. Alright, that's the last big modeling push on this asset. I did get pretty advanced on that back panel. I got more involved in some thought on how I wanted to lay out the topology in a clean fashion. I also used a technique you'll have to go back and review yourself, where I made a copy of the body before I started adding the panel, and later shrink wrapped the new panel to the old body to keep things perfectly cylindrical. If that's stressing you out, don't worry. Just let me know in the comments if you need to see that in more detail. Next, it's time for some UV unwrapping. UV unwrapping is pretty much just how we cut up the 3D geometry so flat 2D texture can be applied to the surface. Our object is mostly cylindrical, so UV unwrapping a cylinder is pretty straightforward. We want to place seams at both ends, and one cut down the back. To place a seam, just select the edges you want to cut. Press U to mark a seam. I'll do a little seam placing section on our model in time-lapse mode now. To view your UV map, just open up a new window by right-clicking and splitting the view vertically. Go to the UV editor. Take the object you've marked seams on. Select everything and press U, Unwrap. Let's preview the unwrap. Hold down Z and go into Material Preview. Now split the left pane again horizontally. Open the shader editor. Let's drop down an image node by pressing Shift-A and searching Image. Create a new image and make it a color grid. Plug this image into the material's color input. Now we can see the grid on the model. Check it to make sure the model is primarily coming up with a square grid. This technique will show you if you have areas that are stretched or not square. Let's apply this temporary material to every other object in the scene. To do so, press A to select all in object mode. Holding Shift, select our base with the new UV material. It'll be highlighted in a lighter orange to show you it's an active object, or the last selected object. We can link the material from this object to everything else. Just press Ctrl L for link and link materials. Now you can continue unwrapping everything else in the scene. Note that our cable is still a curve, and a curve cannot be unwrapped. If you wish to unwrap this, you have to convert it to geometry. Let's get rid of our modifiers first, so those aren't applied during conversion. Just press the X on those. Now to convert, just select it, search for Convert in the F3 search menu, and press Convert to Mesh. I was feeling a little lazy on the bolts, so I just selected them, pressed U, and Smart UV Projection. When I'm done, I might select every object and go into edit mode. Then I'll project everything at once. This ensures it all has the same texel density. You can tell because the squares on the images are all the same size. This isn't really necessary, but I wanted to plug the UV add-on called UV Pack Master. It's a paid add-on, but super useful if you want to get the most density out of your map. And that's it for this video. We added more detail, got a bit more advanced with modeling, learned about arraying along a curve, as well as creating cables with curves. We touched on UV unwrapping as well. As is, this model has really been created for clean production. In the next video, we'll cover some advanced texturing and lighting techniques to take this thing through to the very end. Obviously, a street light alone is not very interesting, but using the techniques in this series, you can pretty much create any asset that you want. These videos take a lot of time and effort, so please consider subscribing to my Patreon. I promise you won't regret it. I really try to offer value by giving you access to all sorts of 3D assets I'm creating and behind the scenes content. Link to my Patreon is in the description. Thanks again for joining me in all of part 2. I hope you learned something new, and I'll see you next in part 3.